In this lesson, we're going to learn how to set up proportions, check to see if proportions are equal, and use proportions to solve word problems. So first of all, let's define what a proportion is. A proportion is a comparison of ratios, an equation that states that two ratios are equal. So that is a proportion. There are several ways a proportion can be written. So there's several different ways we can write a proportion and mathematically be true. One process to determine if a proportion is true is cross multiplication. This process compares the products of alternate numerator and denominator. So here are 4 examples of possible proportions. We're going to see if they are true, and you can see in each one of these the same numbers are used. So we have shown 4 different ways of setting up a possible true proportion using these 4 numbers. So the cross multiplication, we're going to multiply alternate numerator and denominator. And we can see 30 does equal 30, so that is a true proportion. Number 2, 5 times 6, and then 15 times 2, a true proportion. Number 3, 6 times 5, 2 times 15, we have a true proportion. And then the last one, 15 times 2, and 5 times 6. So that is cross multiplication. When working with word problems, the key is to make sure to keep the same units in both numerators and the same units in both denominators. So if we have 8 cats to 12 dogs, we can say 8 cats to 12 dogs. And then when we say 3 dogs to 2 cats, we need to put the dogs to set up a true proportion, and then 2 cats. So cats and cats, dogs and dogs. That's the key when setting up a proportion. And we can see 8 times 3 is 24, and 2 times 12 is 24. This is a true proportion. Okay, we can have 30 miles compared to 2 hours. Is it the same as 1 hour for 15 miles? Again, miles, miles, hours, hours. Cross multiply, 30 times 1, 15 times 2, and we've set it up correctly. So the same units going on the numerator and the same units in the denominator. Tony uses 2 eggs to make 6 pancakes. Allie uses 4 eggs to make 12 pancakes. Our question is this proportional? Cross multiply, 2 times 12, 4 times 6, and yes. Example 8, Joe runs 12 miles in 2.5 hours. Sally runs 14 miles in 3.5 hours. Miles, miles, hours, hours, cross multiply. So 12 times 3.5 is 35. 14 times 2.5. Are these equal? No. So these are not proportional. They are not the same rate. Okay, pause the video, complete these practice problems before moving on to the next section of this lesson. Cross multiplication is applied when finding the value of a variable, which is an unknown value. This process is very useful in word problems. Recall, we just learned that. So here we have some number over 6 is equal to 3 over 9. So we're going to cross multiply 3 times 9, 3 times 6, x times 9 is 9x, 3 times 6 is 18, and now we have a one-step equation. Divide both sides by 9 to isolate x, and x is 2. So 2 over 6 is equivalent to 3 over 9. Number 10, 12 times 4, 3 times x. We're going to isolate x by dividing by 3. X equals 16. So 16 makes this proportion true. Number 11, 6 times 7, 42. X times 10.5. We're going to divide by 10.5. Again, a calculator, very handy for this unit. And x equals 4. Number 12, we're going to cross multiply 20x, 8 times 22.5, 180. Isolate x. X equals 9. That will make this proportion true. Let's look at some more problems. Doggy Daycare provides 24 cups of food for every 16 dogs. There are 88 dogs. How many cups of food? So we can set this up several ways. I'm just going to start with the 24 cups feeds 16 dogs. And then I have to make sure this ratio is cups over dogs. You could have had all this flipped around as long as numerators and denominators have the same units. So we're looking for cups, so that will be x number of cups for 88 dogs. We're going to cross multiply 24 times 88, and then 16 times x, or x times 16. We're going to divide each side by 16 to isolate x, and the cups of food to feed 88 dogs is 132. Corey runs 2/5 miles in 1/4 an hour. How many miles, that's our x, will he run in 7/8 hour? So let's do miles over hour equals miles over hour. So 2/5 mile, it's called a complex fraction, a fraction over a fraction, and 1/4 hour equals x miles over 7/8 hour. So we're simply just going to cross multiply. So 2/5 times 7/8, it's numerator times numerator, denominator times denominator, equals x times 1/4. Now let's isolate x. So we're going to divide by 1/4, but dividing by 1/4 is the same as multiplying by its reciprocal of 4. So if I multiply by 4, these 4's cancel, leaving me with x equals, and then we're going to multiply 4 times 14 over 40, and we get 7/5. And again, you can do that right in your calculator. So 7/5 miles, we can convert that to mixed if you want. 5 and a 7 is 1, 2 left over 5 miles. Okay, you guys pause the video, complete these problems before we pick up with the last section of this lesson. Proportional relationships can be represented in tables and graphs. Showing a constant of proportionality, also called a constant rate of change, and another new term that represents a constant rate of change is called slope. So a constant of proportionality, remember we use the variable k. A constant rate of change or slope, we use the variable m. So two things happen to determine if a graph or table is proportional. To determine if a table of values displays a proportional relationship, 0, 0 is given, so it goes through the origin, and all other entries must show equivalent ratios. To determine if a graph displays a proportional relationship, a straight line, as we saw in the previous lesson, must pass through the origin. So if we have a straight line, we know the entries are equivalent. We have equivalent ratios. So we have to have equivalent ratios and the origin must be included in order for it to be proportional. So let's take a look at example 15. First of all, 0, 0 is given, so we can check that. Now we are going to compare our ratios. And remember, we're going to compare y to x. So we have 6 over 2, 12 over 4, 15 over 5, and 24 over 8. Now we need to simplify these. We have 3, 3, 3, and 3. So we do have a constant of proportionality, a constant rate of change. So the unit rate is 3 slices per student. Let's take a look at a graph. So here we have just a few of the points. I believe it's going to go through the origin, but let's hold off first. And I'm going to write out what is given. 2, 4, that's one entry. 5, these are going up by 2s, 10. 6, 12. 8, 16. And then 10, 20. So let's check the ratios. 4 over 2, 10 over 5, 12 over 6, 16 over 8, and 20 over 10. Is there a constant of proportionality? Yes. So we have 2 days per birdies. So somebody went to play golf and they averaged each 2 days or 2 birdies per day. Make that a little bit neater there. Okay, so 2 birdies per day. So let's see if our ratios check out. Let's see if it's going to go through the origin. So we have in 1 day, 2 birdies. That's our unit rate. And then it does seem to be going down. So up 2 and over 1, up 2 over 1, up 2 over 1. So we have a constant rate of change. It is making a line. Okay, and so it does seem that it would go pass through the origin up 2 over 1, up 2 birdies over 1 day, 2 birdies in 1 day. So yes, now here's the thing. I am not going to connect these dots because we're not going to have a partial birdie. You either have a birdie or you do not. We could have partial day, but not a partial birdie. So we're just going to keep this as a scatter plot. So again, our unit rate is 2 birdies per 1 day. Okay, guys, you finished these practice problems. Make sure you check the answer key when you're finished.